Alright, so today we're reviewing valence electrons, and the objective is to determine the number of valence electrons in different atoms using energy level drawing. So we're going to draw out these different atoms based on their energy levels and be able to calculate the valence electrons that way. So the electrons in the outermost shell or energy level of an atom, that's what the valence electrons are. And it's useful to know because it will help us determine if an atom is going to be reactive or stable. So an atom will have, let's just say this is the nucleus, and we know that is the part of an atom that has the protons and neutrons. We're going to be working with up to 3 different energy levels of atoms. So the electrons are not in the nucleus, they're in this outer region called the electric cloud, and they arrange themselves in different energy levels. The 3 different energy levels we're going to be looking at can contain different amounts of electrons. So this first one can contain up to 2. This next one can contain, up to 8. And the same thing for this last one. So they have a maximum amount of electrons that they can have in each energy level. And if that energy level is not full, that means that the atom is going to be reactive because it is going to try to look for some way to either give off or gain an electron to make that shell full. So this, for example, would be a full energy level because its electrons are completely filling this 2 maximum electron requirement for the first energy level, and it would be happy. However, if you were to have another atom that has 3 electrons, then this would be reactive again because this energy level, the second energy level here, can hold up to 8 electrons, but there is only 1 here. And notice how this first energy level got filled with its maximum amount before we could move on to the next thing. So that's another important part to remember. So the electrons have to go in order from inward out, and they have to have that first shell filled before they can move on to the second. And then this second shell would have to be full before it could go on to the third. So you can't have an electron, 1 in each level or something. You have to first fill this first energy level with 2, this next one with 8, and then this next one with 8. So this will become more clear as we do some of these examples up here. Okay, so hydrogen's going to be first. So how many valence electrons does hydrogen have? First, we need to know some other information. We need to know the number of protons and electrons, really the number of electrons, but because all of these atoms we are working with are neutral, they are going to have the same number of protons and electrons, so we can use the ape strategy, or the ape-man strategy, where the atomic number is equal to the number of protons and the electrons. So remember that this number up here is the atomic number. This one down here is the mass number, which is great, but we don't need to worry about that right now when thinking about valence electrons. So the atomic number is equal to 1, which means that there's 1 proton, and it means that there's 1 electron. So if we were to draw that out, we would have the nucleus, which has just the 1 proton, and the electron has to go somewhere, and it's going to be in the electron cloud in an energy level. So there's 1 electron, and remember this first energy level can hold up to 2, but there's only 1, and this is the only energy level there is. So there is 1 energy level, and there is only 1 electron in it, and that energy level is not full. This is its last level here, and because there's only one valence electron, there's one electron period, but there's also just one valence electron, because that's, you know, as big as the level gets for hydrogen, because it's so small. All right, so there is one valence electron, and because it is not full, it is going to be reactive or not stable. So second example, remember that what the information we need is the atomic number. And we could use the Abe strategy to help figure out how many electrons it is. So the atomic number is 2, means the protons are 2, and the number of electrons are also 2. So if we were to draw that out, we have something, an atom that has 2 protons. We're not going to be worried about the number of neutrons right now, just to keep things simple. And let's see how many energy levels it has. So we have 2 electrons, and that maxes out that first energy level, and we don't have any more, so this is it. There is still one energy level. This time it is full because the maximum amount that first energy level can hold is 2 electrons. And how many electrons are in that last energy level? In this case, the only energy level? 2. So there are 2 valence electrons. It is full, which means it's not reactive. And there's only that one energy level. So on to example number 3. This time we have neon, which is going to have more electrons. And we know that because, again, we look at the atomic number. And the atomic number is the same as the protons, is the same as electrons for these neutral atoms. So there are 10 protons, 10 electrons. So let's draw that up. So, like I said, we got the 10 protons in the nucleus with neutrons, but again, not worried about the neutrons right now. We're worried about the valence electrons. So we have 10 electrons, so we can only fit 2 electrons in this first one, which means that we are going to have to add a second energy level. So far there are 2 energy levels. And if we already did 2 of them, that means we have 8 electrons left. So let's add those. So we got 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10, so we're done. So that's all of the electrons that there are. It fills 2 energy levels. And because the second energy level can only hold 8 electrons, it is full, which means it is not going to be reactive, which means that it is stable, just like helium was. So it is stable because that last energy level is full of 8 electrons. And how many electrons are in that last level? There are 2, 4, 6, 8. So 8 valence electrons. So there may be 10 electrons altogether, but we only care about the last energy level when talking about valence electrons. So they're in the outermost shell. So even though there's 2 in here, we're not concerned about that. We're concerned about how many are in the last energy level.